Hello, I welcome you all. The problem reads the 2 kg pendulum bulb moves in the vertical plane with a velocity of 8 meters per second. When theta is equal to 0, determine the initial tension in the cord. And also at the instant the bulb reaches theta equal to 30 degrees. Neglect the size of the bulb. Right, both problems are coming from the Engineering, Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So we have this pendulum, okay, that moves in the vertical direction, okay, like so. And then we've been told that at theta equal to 0, the velocity is 8 meters per second, and we've been asked to find the initial tension in the cord, that is at theta equal to 0, as well as the tension when theta is equal to 30 degrees. Okay, right. So let's begin. Let's draw the free body diagram. So we have the weight of the bulb, like so. And then when we section this, let's say there, we are going to have the tension. We have the tension like so. Of course, this is another axis which we are going to call N. And then from this weight, we are going to have components. One component in this direction like so. This is from the weight. We do have a component in this direction and another component in this direction. Right. There we go. So let's say we have our motion. We are moving from down, from 0 going up like so. Right. So this is our N. This is our T. Okay, so this is our tension. This is our W. So if this angle here is theta. If this is theta, this becomes 90 minus theta, therefore this is theta, right? So this one here is theta. Great. So this is W, which is just equal to mg, right? Then this one is W sine theta, and this is also W cos theta, right? So let's write down the equations. So we do have the kinetic diagrams, one in this direction like so, and another one in that direction like so. So this is our MA T. This is our MA N. All right. So let's write down. This one doesn't look very straight to me. Let me write it. Somewhere there like so. Okay, I think this is better now. Okay, something like so. Alright, this is W sine theta. So let's write down the equations. Let's start with the t. So say summation of forces along the t-axis is just going to be equal to mat, going in that direction being our positive. Therefore, we'll have the following. I'll have minus W cos theta, okay, equal to mat. Therefore, our AT is just going to be equal to minus W cos theta divided by M, which is just equal to mg cos theta, okay, divided by M, and then our AT is just equal to g cos theta. Alright, which is minus, okay. Alright, so then we want to find the tension, but we will need to find the acceleration, right? Which will be the function of theta that we are going to use later on in the equation. So we are going to use this equation A ds equal to B dv. This is coming from our B ds dt and our A dv dt, making dt subject to the formula, and we are find that particular equation. Alright, so you know that S r theta, you can write this as just S is equal to r theta, and therefore this is also true. The S is just equal to r d theta, right? So our ds here is just going to be equal to r d theta. So with that in mind, we can replace this there and write this. It becomes 80 r d theta, right, is equal to v dv. Then we integrate this, integrating from 0 theta naught is 0 to theta, and then v naught is 8 to v. So replacing this particular, we calculated this, we replace it here. So this just becomes minus g r cos theta d theta equal to v dv. Okay, there we go. So if we integrated this just becomes minus g r sine theta, right? This is just equal to b squared minus 8 squared divided by 2, and therefore our v squared will just be equal to minus 2g r sine theta, okay, plus plus 8 squared, right? So with this equation, we'll leave it like this to the 8, yes. So let's now sum up the forces in the end. Summation of forces in the end equal to AN, like this, where our AN is the centripetal acceleration, right? And then this one is going down, being our reference. So we do have T plus W sine theta equal to mv squared divided by rho. All right, so there we go. What do we have? So our T therefore will just be equal to mv squared divided by rho minus W sine theta. Then our T is just going to be equal to v squared divided by rho minus G sine theta. So we found v squared is equal to what is v squared? We said it's minus 2 GR sine theta plus 8 squared. Therefore our T is just going to be equal to m. We replace that there, just becomes minus this like so, sine theta plus 8 this divided by rho, and our rho is just equal to 2, and then we do have this component which is minus G sine theta. Okay, all right, so this just becomes our T, therefore will just be equal to m. So m, so this can cancel this and this cancels, so we'll remain with the just GR, which is a 2. Okay, so let me write this. So one part of this cancels, then here just becomes 64, so this just becomes 32, right? So this just becomes minus our R is just equal to 2, so this is 2G sine theta minus G sine theta plus 32, like so. Right, so working out this just becomes equal to m minus 4 G minus 3 G sine theta plus 32. Okay, so our m is just equal to 2, our G is equal to 9.81, our theta will just change depending on which one we are getting. So the tension when theta is equal to 0 degrees, this is just going to be equal to 0 degrees. This is equal to 64 newtons. Okay, 64 newtons. There is a 64 newtons. And then when t at theta equal to 30 degrees, this just becomes that's minus 3 by 9.81 by 0.5 plus 32. Okay, and then everything by 2. So this just becomes a 34.57 newtons. Right, let me just indicate this one to say this one is case 1. There are two problems here. This is case 1, which is 13-80. Okay, I guess we are done for this particular problem. Let me just outline. I guess we are done. And I hope this particular problem video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.